Good morning, children. This is 11th Physics, Chapter 3, Motion in a Straight Line. Today, we are going to start with the topic acceleration. Here you can see that the car is moving with a variable speed. The speed of the car over here is changing. Here we can see that the car is changing its direction. Same is the case with the bus as well as with the bike. They are moving with a variable velocity. So, whenever the velocity changes, acceleration comes into picture, right? So, velocity, how can we change velocity? So, velocity, children, it changes when the magnitude of the speed changes. Suppose initially the bus was moving with a speed of 30 kilometers per hour, and then it speeded up on the highway and it increased its speed to 60 kilometers per hour. So as the speed of the bus changed, its velocity is changing. So velocity can be changed by changing the speed or by changing the magnitude. Second, velocity can be changed by changing the direction of motion. Suppose initially the bus is moving on a straight highway, then the bus has to take a turn, right? So when the bus is taking a turn, its direction of motion is changing. So as its direction is changing, its velocity is changing. And as the velocity is changing, the acceleration exists there, right? Velocity can be changed by changing both. That is, magnitude is also changing and the direction is also changing. Right. Now here we are having two examples. Here we can see that the car is moving with a constant speed of 80 kilometers per hour and the car is moving on a straight highway. Similarly, here in the second picture, we can see the aeroplane is moving on the straight path with a constant speed of 1000 kilometers per hour. Now, as, as both the car and the aeroplane, they are moving with a constant speed, means the magnitude is constant, as well as they are moving on a straight path, means the direction is not changing. So velocity is not changing, velocity is constant. So as the velocity is constant, there is no acceleration involved in this. Right? Now let's see what is acceleration. We have done in our lower classes also. Acceleration is the rate at which the velocity changes. Acceleration is the rate of change of velocity. Acceleration is the rate of change of velocity. Means with what pace the velocity is changing. Right, children? Here we are having two examples. Here as you can see that the car is moving on a straight path, but its magnitude of velocity, that is its speed, is changing. Suppose initially the car was at rest, so its speed is 0 kilometer per hour, and then it started, and when it is starting, suppose its speed is 20 kilometers per hour, and then it speeds up and its speed becomes 60 kilometers per hour, and then it has to enter a city area, market area. So its speed again decreases to 20 kilometers per hour. So here you can see that the speed or the magnitude of velocity is changing. Initially it was 0 kilometer per hour, then 20 kilometer per hour, then the car reached on highway, so its magnitude changed to 60 kilometer per hour, and then it entered a marketplace, so its velocity or its magnitude became 20 kilometers per hour. But throughout the car was moving on a straight path. The direction was not changing, but the magnitude was changing. So as the magnitude was changing, there was change in velocity. So here acceleration exists. Right, children? Now second case, here we can see that the object is moving on a circular track. Here the object is moving on a circular track. Now here the object is moving with constant speed. जो उसकी speed है, suppose an athlete is running over the circular track. The athlete is running over this circular track. Now the athlete is running with constant speed. Suppose उसकी speed constant है. Suppose the athlete is running with a speed of 30 kilometers per hour. Right? Now its speed is constant, but on a circular track at each and every point, its direction is changing. So as there is change in direction, the velocity is changing. And due to the change in velocity, the acceleration exists. So acceleration exists here. So what is acceleration? Acceleration is rate of change of velocity is your acceleration. So we can write the symbol for acceleration is A. So we can write A equals to change in velocity, that is V minus U upon time taken, that is T. So this we know. A is V minus U by T, that is V is the final velocity, U is the initial velocity upon time. Now, A is a vector quantity and its direction is same as the direction of the velocity, right? That is change of velocity. Very important here, its direction is same as that of the change in velocity and not the simple velocity. Right, beta? Next is its SI unit. So we can easily write down the SI unit of velocity acceleration. Acceleration is what? Change in velocity by time. Acceleration is change in velocity by time. So its SI unit is meter per second square. And its CGS unit is centimeter per second square. And similarly, we can calculate the dimensional formula. Mass is 0, so m to the power 0. Length, meter is 1, so L to the power 1. Time is in denominator, that is raised to power 2. When it comes up, it comes minus 2. So T to the power minus 2. So this is the dimensional formula of velocity. Now, here we are having two acceleration. First is the average acceleration. So average acceleration is defined as the ratio of total change in velocity. As we know, acceleration is what? Change in velocity by time. So here we are talking about average. So we have to do total, right? So here it is total change in velocity upon total time taken. Right, simple. So it is total change in velocity is del V, total time is del T, right? So that is V2 minus V1 upon T2 minus T1, means how much the velocity has changed, right? So that is V2 minus V1 upon total time taken is T2 minus T1. So this is your average acceleration, which is denoted by the symbol A to the suffix AV. Next is instantaneous acceleration. Instantaneous acceleration is at that particular instant of time. Means it just a second पे मैंने आपको बोला उस not even second, microsecond, or you can go to millisecond. So here the time t is very zero. The time t approaches to zero. उससे second आपको बताना है. So time is very small. So del t tends to 0 and your del will change to d. Del changes to d when your parameters you are taking it very near to 0. So in that case, del will change to d, right? So this is dv by dt. But instead of in this equation, instead of v, I think we can write ds by dt, because velocity is what? ds by dt, rate of change of displacement. So if I put instead of velocity here ds by dt, then instead of velocity I am putting here ds by dt, then what I will get? I will get d square s by dt square. D square s by dt square. So this is the same thing, d square s by dt square. Here you will see that velocity is a vector quantity, acceleration is a vector quantity, displacement is a vector quantity. So we are having the symbol of vector, that is the arrow over its head, right? Next chapter we are going to study it in detail. Now children, acceleration, it is of three types. One is acceleration, there are of three types. Acceleration can be positive, negative or zero. Right children? Let's see how. Say children, when over here you can see the picture of the car. Suppose here initially the car was at rest, so the initial velocity of car u is 0. Then you can take the unit as kilometer. I'm having kilometer per hour, right? It's 0. Car was at rest. Now you have started the car and the car attains a speed of suppose 50 kilometers per hour in about 5 minutes. After 5 minutes, you are at the speed of 50 kilometers per hour. So here you will see children that the initial velocity is 0 and the final velocity is 50 kilometers per hour. So as the velocity is increasing, the change in velocity, that is v minus u. The change in velocity is v minus u, that is 50 minus 0, that is 50. So change in velocity is positive. So as here the initial velocity is smaller than the final velocity, or the final velocity is greater than the initial velocity, the acceleration is said to be positive acceleration, right children? So when the change in velocity is positive, the acceleration is said to be positive acceleration. Here you can see, here it's shown, that is positive acceleration means velocity is increasing with time, right children? Now let's talk about the next second case, and that is negative acceleration. So negative acceleration is you are moving in your car and finally you are going to approach your house, right? So when you are approaching towards your house slowly and steadily, you are going to slow down and finally you will stop. So suppose before your house your initial velocity was 80. Oh, you were not there with your parents, you were alone. So you're moving very fast and you were moving with a speed of 80 kilometers per hour. And finally, when you reached home, your velocity became 0. So here you can see as the velocity is decreasing, as the final velocity is less than the initial velocity, the acceleration is said to be negative acceleration. So here we can see negative acceleration means velocity is decreasing with time. Right children? Next we can see zero acceleration. So zero acceleration beta, it shows you that its velocity, initial velocity and final velocity were same, means constantly you were moving with a speed of 30 kilometers per hour initially also and finally also. जिस time पे आपने check किया that we started, that was 30 kilometer per hour. जिस time पे आपने you finished the checking, at that time you noticed your speed, your velocity, that was again 30. Right children? So 30 initial velocity 30, final velocity 30. So change in velocity is what? V minus u. That is 30 minus 30, it's 0. So when the velocity of the car is constant, so here you can see the car is constantly moving with a velocity of 30 kilometers per hour. So as its velocity is constant, the acceleration is 0. So 0 acceleration means velocity is uniform, velocity is constant. Right. Now, this was about acceleration. Now we are going to start with the position time graph. Position time graph. And children, we have already done the derivation for equations of motion, right, by calculus method when we were doing the differentiation and integration, right? So we are not going to repeat that, and the graph method, that I will just send you in the notes, because the same we had done in ninth. Calculus method we have already done, right? So after these graphs, your chapter is over. Okay, children? So this is your position time graph. So position time graph means you are going to have on your y-axis, you are going to have the position, and on your x-axis, you are going to have the time. Yes, children? Sure, let's start. So first, let's try to understand about the graph. Suppose here you can say this is your y-axis and this is your x-axis, right? Now, this is your graph line. The black one, you can see, this is your graph line, right? The black one. Now, slope. What does slope mean? Slope means the inclination of the line with the x-axis. It means x-axis के साथ what inclination it is having, right? What angle it is forming with the x-axis. So that is the change in y coordinate upon change in x coordinate. So let us select 2 points on this line. Suppose this is my, let me zoom it little bit, just a second, children. Okay, I think this is enough. Okay, so what we are doing, children, is we are selecting 2 points, this one and this one. Suppose this is my point number 1 and this is my point number 2. So we said that slope is change in y-axis, change in y coordinates upon change in x coordinates. So children, the coordinates of point 1 are what? X1, Y1. है ना बेटा? X1 or Y1. Similarly, the coordinates of point 2 are what? X2, Y2. Right? Now, when we are moving from point A to B, when you are moving from point 1, sorry, not A to B, from 1 to 2, its y coordinate is changing. So here at point 1, the y coordinate is y1, and as it is approaching towards point 2, its y coordinate changes to y2. So change in y coordinate क्या हो गया? So change in y coordinate is y2 minus y1. So change in y coordinate is y2 minus y1. And change in y coordinate is what? y2 minus y1. Right, children? Now, if again we are approaching from point 1 to 2. So again the x coordinate over here is x1 and x coordinate at point 2 is x2. So the x coordinate is also changing. So the change in x coordinate is x2 minus x1, right? The change in x coordinate is x2 minus x1. So that is your slope. That is your slope is change in y coordinates upon change in x coordinates. And for change, we are showing the symbol del. Right, children? Now, so change in y is what? y2 minus y1. And change in x coordinate is what? x2 minus x1. Now, if you see beta, if we form a right angle triangle here, this is what change in y coordinate and this is what change in x coordinate. So, if we take the trigonometric function 10, then we know 10 is opposite by the adjacent side. So children, here the opposite side is what? If I take 10 theta, if we calculate 10 theta over here, then 10 theta is opposite side is del y upon the adjacent side, that is del x. So fine, okay, del y by del x is what? That is slope, which is equal to 10 theta. So children, your slope equals to change in y coordinate upon change in x coordinate, that is y2 minus y1 upon x2 minus x1, which is equals to the 10 theta, where theta is the angle between your graph line with the x-axis, right children? Now this was for the straight line graph. Now if we are having a curved graph, then what we are going to do? Then the point at which You want to find out the slope, means जिस point पे आपको slope find करना है. Suppose I want to find out the slope at this point. Suppose we want to find out the slope at this point. Now, as the point at which we are finding out the slope, suppose here its time is t. So here time t is very small because we are considering only a point, right? So at this point, the slope changes from del y to del x. It changes to dy by dx because your time t tends to 0. Right, children? So the point at which you want to find out the slope, you will draw a tangent. We know how to draw a tangent, right? We will draw a tangent and then we will measure the angle with the x-axis. How we will do? We will draw a parallel line to x-axis, right? And then we will draw the point at which we want to find out the slope. There we will draw a tangent. The angle between them, right? The angle between them, suppose the angle over here, suppose it is 30 degree. Suppose the angle is 30 degree. Now beta, we know the value of 1030. We know the value of 1030, that is 1 by root 3. Yes, 1 by root 3. So this will give you the slope at this point of the graph. Okay, children. So let's now cover some important points for the graph. First thing is for the displacement time graph. For the displacement time graph, from the displacement time graph, we are going to get one physical quantity, and that is velocity by finding the slope. So from displacement time graph, we can get the value of velocity by finding the slope, right? And from velocity time graph, we can calculate two physical quantities. We can calculate two physical quantities, right? So which two physical quantities? First is by calculating the area under the graph. If you want to calculate the area under the graph, then that will give you the value of displacement. This we have done. But children, if we find the slope of this line, if we find out the slope of this line, then the slope of velocity time graph will give you the value of acceleration. So from displacement time graph, we are going to get one physical quantity, that is velocity, by finding the slope. And from velocity time graph, children, we will get two physical quantities. First is displacement by finding the area under the graph. And second is acceleration by calculating the slope of the graph, right? So the slope of distance time graph, it gives you the instantaneous velocity, means velocity at that instant of time, right? Next is velocity time graph area. Suppose this graph, if I extend it like this, that it is this, and then it has gone like this and like this. So here you will see that this area is in the positive direction and this area is in the negative direction. So suppose what I do is I find out the area under the graph. So I will find out the area of this portion as well as this portion. So this would give me the area under the graph. So if I add them without considering the signs, means I'm just adding them as it is. Simply I'm adding them without considering the negative sign. So when I find out the total area without considering the sign, we will get the value of distance. And when we are considering the sign, that is, suppose this area is 20 plus 20 and the area under is suppose minus 8. So if you do 20 minus 8 and then you are going to get 12, then this 12 meter gives you displacement, right children? If you are simply adding, that is 20 plus 8, that is the distance, that is 28. But if you are considering the sign, because 20 is in positive direction and 8 is in negative direction. So when you consider sign, you will get the value of displacement. Now let us see few position time graphs. Now, children, it's very important. Be careful. Now, velocity equals to ds by dt. That is, this is instantaneous velocity, right? Now, this is the graph of position time graph, s versus t. Now, that here you can see that the slope line and x-axis, the angle between them is 0. Theta is 0. So children, as theta is 0, tan theta, tan theta gives the value of velocity. So if theta is 0, tan theta is 0 because sin theta 0 hota hai, right children? So tan theta 0 means velocity is 0. Okay. So as theta is 0, velocity is 0 means the particle is at rest. So we know this is the graph for object at rest. Right? Next graph. Here we can see that this is your slope line and the angle is theta and this angle is constant. The angle is not changing. Right? You're getting a straight line. Angle is theta and theta is constant. So as theta is constant, the value of velocity is also constant. And if velocity is constant, children, then acceleration will be 0 because acceleration is what? It is change in velocity. But velocity is not changing, it is constant. So particle is moving with uniform velocity. Next is, here we can see that this is the angle theta. But if you see, the angle theta is increasing with time. So as theta is increasing, velocity is also increasing. And if velocity is increasing, then change in velocity will be positive because finally velocity बढ़ रही है. Change in velocity is positive. Acceleration is positive. Acceleration is positive, right children? So particle is moving with increasing velocity and positive acceleration, right beta? Now next graph, if we see the here the angle theta, it will go on decreasing because finally you see it is becoming parallel to time axis, and once it becomes parallel to time axis, the theta will become 0. So the angle theta is decreasing with time. So as the angle theta is decreasing with time, velocity is also decreasing with time and your acceleration will be negative. That is retardation. Right? Now last, that is, here you can see this is your displacement time graph and here you can see this is a straight line graph. But here the angle is greater than, the angle theta is greater than 90 degree. So as angle is greater than 90 degree, but theta is constant, but it is greater than 90 degree. So tan theta value you will get negative. So your theta is constant, but it is negative. So your tan theta will be negative. As tan theta is negative, velocity, that is slope, will be negative. And you are going to get, as the velocity, it will be negative, but it will be constant. So as velocity is constant, the acceleration will be 0. Here beta, if we are saying velocity is negative, what does it mean? Means velocity is negative means the displacement is negative, means the object is returning towards the origin, returning towards the point of reference. Okay, so bye bye children, we will continue with the next topic, that is velocity time graph, in the next class. Okay, bye children.